Nucleophilic addition. This is where a nucleophile adds to an area where there's some partial positive nature or partial positive charge. So let's look at nucleophilic addition as a step. And in some cases, it's a little bit similar to coordination in that it is making a new bond. But let's look at this nucleophilic carbon, which could have originated from methyl lithium. Say, for example, we'll have a negative charge here. And we'll see what happens when we react this with a ketone. So we'll just use the pentanone. That would be 3-pentanone. It's on the third carbon. Now, right here we have a partial positive charge, and we'll have a partial negative charge up here on the oxygen. And we have a full negative charge on this carbon. So these electron pair will associate or do a nucleophilic addition, or some people call it a nucleophilic attack on this carbon. Now, when we draw a mechanism, we have to be careful. If we just drew it like this, now we would have a carbon that has 5 bonds to it, 5 areas of electron density. That would be 10 electrons. Can't have that, so we're going to move some of those electrons away up to the oxygen. So that's going to happen at the same time. And what we'll get is this, with the negative charge up there on the oxygen and a new methyl group right here. And we'll put a little circle around this negative charge so we don't think it's a bond. That would be something different. So that's one example. Let's do another. Let's see here. Let's go with hydroxide. So we have hydroxide, and we'll add it to acetonitrile. This will be a reversible reaction. So, which carbon is this going to attack? Is it going to attack this one or this carbon? Well, this one has electron donation, or kind of a neutral electronic character because it's around the hydrogens, whereas this one has this electron withdrawing group right here, this nitrogen. So, while everything on this molecule has a 0 formal charge, we should note that this one has a little bit more positive character right there. So this is where it's going to attack. So we'll draw the attack over to that carbon. And similarly to this carbon up here, this one would then have 5 bonds. So we'll draw some of them leaving towards the nitrogen. And we'll end up with this. We have our methyl group right here. We have our carbon that's still there. I'll draw it in. I'll draw it in. And then we still have a double bond because we only drew one arrow over. So we'll have our nitrogen, and now we'll have a negative charge on the nitrogen, which we could see if we just put in the extra electrons here. We could count them up. It has 6 electrons. It used to have 5. Now it's got a negative charge up there. And a lot of times it's nice to write the negative charges up there, so we'll write that. And we've formed a new bond with our hydroxide, so we've got that. How about just one more? Now, so far I've had negative charges. Now, this was a very reactive species. This one's fairly reactive. Let's look at something where it doesn't have a negative charge located on it. We'll just pick water. Now, water can react with an acid chloride. These are fairly reactive. Now, if you were to do this reaction in the lab, I would recommend doing it inside a fume hood, since one of the byproducts you'll probably get is hydrochloric acid or HCl gas coming off, and that can be a little bit irritating if you inhale it. Ask me how I know. All right, so here we have this, and we have our lone pair. Our lone pair can now attack this carbon, which has a positive charge on it. And this carbon's fairly positive because we have electron withdrawing from the oxygen and from the chlorine. And we'll, again, put the electrons up on the most electronegative element there, similar to this reaction up here. We're just dealing with a more reactive species. So now we have our negative charge up there. We're going to have a positive charge down here because we've got 3 bonds to the oxygen. We still have our chlorine there. And then later this can collapse down and form some other product. It would substitute out into the acetic acid, and then HCl would leave, but that's not what this reaction is about. So we have nucleophilic addition. In this case, we have a weaker nucleophile attacking right here, and then we move the electrons up, make this product right there. So that's a little bit about nucleophilic addition, one of the other steps that we'll see repeated in more complicated mechanisms.